In the Everglades, there is few wetland habitats more diverse than tree islands, and no two tree islands are exactly alike. Each is a semi-tropical wonderland. Historically, the Everglades spanned 4,000 square miles from Lake Okeechobee to the southern tip of Florida. This unique ecosystem was largely a mosaic of sawgrass marsh ridges alternating with deepwater sloughs, wet prairies, and dotted with elevated tree islands that numbered in the thousands. Tree islands are slightly elevated areas covered in woody and other vegetation surrounded by a sea of watery marsh, ranging from a mere 6 inches to as much as 4 feet above the surrounding marsh surface.
Tree islands in the Everglades are a really interesting feature. They're one of the elevated areas within the marsh, so they're a higher piece of ground than the rest of the marsh. And they're very interesting because of that slight elevation. They have a lot of different plants and animals on them than are found in the marsh.
Tree islands are important upland habitats in the Florida Everglades. They are surrounded by water in the traditional river of grass. And they're more than that. They collect nutrients and sediments that support larger trees and woody vegetation, and they provide excellent habitat for terrestrial wildlife.
Tree islands can support 2 to 3 times more biodiversity than the surrounding marsh habitat and provide habitat to a variety of species including wading birds, deer, bears, and alligators. Tree islands also play an important role in the cycling and storage of nutrients like nitrogen and phosphorus within the Everglades. Tree island soil has been found to contain up to 100 times more phosphorus compared to marsh soil, making them biogeochemical hotspots. Tree islands are culturally significant to Native American tribes, including the Miccosukee tribe of Indians and the Seminole tribe of Florida.
And so you get a lot of diversity on the tree islands in terms of vegetation. And this is important to the Miccosukee because the Miccosukee utilized these tree islands more than just living. They collected vegetation for building homes, for firewood, for getting medicine, for planting their corn. A lot of cultural significance is tied to the actual tree islands. One of their big ceremonies in the year is the Green Corn Dance, and they historically would grow corn on the tree islands, which are then utilized for those ceremonies. But they don't do that anymore because the water's too high or the tree islands don't grow the corn that they used to grow.
Native American tribes aren't the only ones with a long history in the Everglades. The Florida Gladesmen have made the Everglades an integral part of their culture for more than 150 years.
We have camps on them. We go out there, for recreation. It's a great place to clear your mind. It's quiet. So we enjoy the tree islands for that aspect of it.
Human alterations throughout the Everglades have drastically impacted tree island hydrology. Major efforts to drain the Everglades and its watershed for agricultural production began at the end of the 19th century and would later attract farmers and visitors to the region. In 1907, Governor Napoleon Bonaparte Broward and the state of Florida established the Everglades Drainage District, creating 225 miles of canals, including the Miami Canal that connects Lake Okeechobee to northern Biscayne Bay. This 77-mile canal acted as a drain and allowed water to quickly flow out to the ocean faster than it could be replenished, creating thousands of acres of dry land for farming. Then, in 1948, Congress authorized the Central and Southern Florida Project for Flood Control and other purposes, following catastrophic flooding across South Florida caused by 2 back-to-back hurricanes in 1947, to protect urban areas from future flooding and to provide water supply during dry periods. A critical component of this project was to create 3 water conservation areas, or WCAs, in the low-lying marshes of the Central Everglades. Completed in 1962, these water conservation areas total more than 1,300 square miles and are partially or completely enclosed by levees and canals to store large quantities of water that would be used for agriculture and urban water supply, or discharged southward for flood control purposes. Water Conservation Area 1 is also known as the Arthur R. Marshall Loxahatchee National Wildlife Refuge. The dredging of canals and construction of the water conservation areas fragmented and compartmentalized a large portion of the historic Everglades. With this altered hydrology, especially the slow-moving water that defined the River of Grass, more than half of the tree islands that once dotted the water conservation areas were degraded or lost to drainage, which led to fire followed by flooding, and invasive plants, leaving behind ghost tree islands.
So about 100 years ago, there were three main factors that caused tree islands to disappear. The first factor was a total disregard for the utility and importance of tree islands in the Everglades, and in fact, a total disregard for the Everglades as a whole. That led to the second component of Everglades degradation, and that was drainage. It was due to drainage, I would say 40 to 50% of all the tree islands in the Everglades got burnt away, and another 30% lost elevation due to soil subsidence. And then the third phase was that humanity realized that by draining the Everglades, you actually reduced their water supply. And so we impounded the entire system. We created water conservation areas. So by 1985, water levels went up significantly. And what we did with all the islands that subsided, they all drowned. And what we're left with is these ghosts of tree islands that are made up mostly of cattails.
Today, there are many agency efforts underway to improve water flow characteristics throughout the Everglades ecosystem while maintaining municipal and agricultural water supply and preventing flooding. The Comprehensive Everglades Restoration Plan, or CERP, is the largest restoration project in U.S. history. It is a joint effort between the U.S. Army Corps of Engineers and the state of Florida to improve the quantity, quality, timing, and distribution of water flows to the northern estuaries, central Everglades, and Florida Bay, while increasing water supply for municipal and agricultural users. The Central Everglades Planning Project, called CEP for short, is one of the many projects that make up CERP. CEP is broken down into multiple construction phases due to the magnitude of the project. CEP North is one construction phase and focuses on improving water flow characteristics in Water Conservation Area 3A. One component of the CEP North phase includes filling in approximately 13.5 miles of the Miami Canal with spoil material, dirt that was removed when the canal was originally dredged. Then, vegetated hammocks modeled after tree islands will be constructed within the backfilled canal. These vegetated hammocks will help serve as hydrological speed bumps, further slowing the water flow to velocities more typical of the historic River of Grass. The vegetated hammocks will also provide essential dry habitat for many species, similar to the tree islands that once dotted the landscape. The design and construction of these vegetated hammocks will incorporate the latest science and system-wide monitoring data provided by a group known as Recover.
Recover is a multi-agency group of scientists, planners, engineers who all come together to apply scientific knowledge to Everglades restoration.
Recover, an acronym for Restoration, Coordination, and Verification, is an interagency body that was formed in 2000 to provide the science behind CERP. Recover and the CEP design team previously met at the Arthur R. Marshall Loxahatchee National Wildlife Refuge during the planning phase of CEP.
So back in 2012, Recover got together right here at the Loxahatchee National Wildlife Refuge, and we came together to pull an adaptive management plan. And as part of that adaptive management plan, the idea is that you continue to use new science to inform decision-making, to reduce uncertainties, and to improve success. And as part of that vision, the idea was that Recover would revisit the design and construction of these engineered tree islands in order to ensure that we are capturing the most recent science and using that to inform our design. And in that way, it will help to promote success.
To address the many uncertainties of building vegetated hammocks, in the summer of 2022, a 3-day workshop for Everglades scientists, engineers, and other experts specializing in the science of tree islands was held at the Arthur R. Marshall Loxahatchee National Wildlife Refuge in Boynton Beach, Florida, to answer the question, how do we engineer the building of vegetated hammocks within the backfilled Miami Canal as a part of SEP North?
The question is, can we add value to that backfilling? Because the northern part of 3A has lost 90% of all the tree islands that used to be there. So can we truly enhance the restoration effort by building these tree islands? And we hope the answer is yes.
The 3 main goals of the workshop were to summarize the current understanding of tree islands in the northern part of Water Conservation Area 3A, then to apply this understanding to inform the design for engineered vegetated hammocks in the Miami Canal, and develop a plan to ensure their sustainability.
It's an excellent opportunity to have a workshop like this to gather together scientists from all different types of disciplines and managers from different areas and get to talk about the shared vision for restoration under the Comprehensive Everglades Restoration Plan.
To kick off the workshop, participants learned more about LILA.
So LILA is the Loxahatchee Impoundment Landscape Assessment. It's a project that was developed to assess how the system would respond to different hydrological scenarios that could be manipulated by people. And so there are a number of macrocosms that are comprised of tree island, ridge, and slough habitats and are exposed to different hydrological conditions. And so it's sort of like a living laboratory and a place that scientists can come to evaluate kind of how those changes will impact other environmental elements. And so LILA provides us an opportunity to see how a man-made tree island was engineered from scratch in a controlled setting. And so bringing folks here, they can see what a tree island looks like, learn a little bit of how the creation of a tree island took place, and get them out in the field and kind of see what we could create as a result of this workshop.
The next 2 days of the workshop were spent at the South Florida Water Management District headquarters in West Palm Beach, where participants attended presentations and discussed critical topics with panelists. During these sessions, engineers and project managers provided an overview of the modeling and construction of vegetated hammocks for SEP North as envisioned in the original planning report.
Number 7 is the Miami Canal backfilling, which is the purpose of today's or this week's workshop.
Scientists presented their latest findings on the plants, wildlife, and hydrology of tree islands, and discussed the importance of tree islands to the Native American tribes and other stakeholders. These sessions provided participants with the latest on tree island science, providing the crucial background information needed to develop plans in the next breakout group sessions. In these breakout groups, participants brainstormed different ways to construct and maintain vegetated hammocks sustainably in the backfilled Miami Canal.
One of the components of this workshop is to separate into smaller working units. We call them breakout groups. That way, there's a high value there because we're able to spark conversation and, really getting to a collaboration which eventually leads to improvements.
Breakout groups were provided with background information and discussion questions to help them develop draft plans for designing, constructing, monitoring, and maintaining the vegetated hammocks. Discussion questions included: 1. What are the important design elements? 2. What are the construction considerations? 3. How should the constructed islands be monitored and maintained? 4. How will their success be defined?
When you're in the breakout groups, be free to think of anything outside the box. There are no wrong answers, there are no bad questions.
Each breakout group was led by a facilitator who guided the discussion and helped synthesize all the information discussed into a draft list of recommendations. Breakout groups then gathered to share the results of their individual discussions and present the most important points that came out of each session. At the end of the workshop, several participants reflected on how these sessions helped them and other participants understand the complexities of building vegetated hammocks.
The design aspects that I thought was the most important for this project in the Miami Canal, immediately I thought about elevation. Then I thought about substrate and of course vegetation. But the thing that really struck me was learning about the design and constructability, things that I never really dawned on me, that you really have to consider access and compaction and how well will the island act to divert the flow, because that's really one of the main objectives of SEP. So I think the workshop was very, very informative in that respect.
I had a couple big takeaways from the workshop. One was, aside from all of the research and study we've done on tree islands, there's still so much to know. And these engineered tree islands are going to give us a great opportunity to further that research and science. In addition to that, being an ecologist and not a construction engineer, the amount of work and study and engineering it takes to build a tree island in a very remote area.
In the weeks following the workshop, Recover synthesized all the information gathered from the workshop to create 8 workshop products that would be provided to the SEP North design team as recommendations to refine the initial vegetated hammock design originally developed as part of SEP.
This workshop did a deep dive into the processes that make for a healthy tree island. And based on that deep dive, the products included plant design, the spacing of those plants, the types of plants that should be planted, the spacing of the tree islands, the size of the tree islands, the height of the tree islands.
The first workshop product is a design plan for constructing the vegetated hammocks. As part of SEP North, 8 new vegetated hammocks will be constructed, and 6 additional vegetated hammocks will be constructed to augment existing spoil mounds. To mimic tree islands, Recover recommends that the vegetated hammocks have a teardrop shape and vary in size and elevation with small, medium, and large hammocks. Each constructed vegetated hammock should also have higher elevation at the head or top of the vegetated hammock, with elevation declining towards the tail or bottom of the vegetated hammock. Elevated areas will provide essential habitat for birds and other animals when water levels are high. Recover also developed planting scheme recommendations. Which species of plants should be planted and how should they be planted to promote their survival?
The next step is to continue working with the planners and send out crews to evaluate the composition of the spoil banks that are needed for backfilling, but also doing an in-depth vegetation analysis of the plants on either side of the Miami Canal to look at which ones can be preserved and actually used to plant on the tree islands.
Recover recommends planting the same species that naturally occur on tree islands in the Everglades. Flood-intolerant species, such as gumbo limbo and Florida strangler fig, should be planted on the head of the vegetated hammock where the elevation is higher, and flood-tolerant species, such as pond apple and Carolina willow, should be planted at lower elevations near the tail. The next workshop product outlines the potential impacts of construction on the hammock and the surrounding habitat, with recommendations on how to reduce the impacts. One major construction concern is soil compaction by the heavy machinery that will be used to build the islands. Compacted soil could reduce root penetration, soil aeration, and groundwater connectivity, ultimately lowering plant survival. Recover recommends selecting equipment and substrate material to limit compaction during island construction. The next 2 workshop products developed by Recover were the Monitoring and Maintenance Plan and Revised Management Options Matrix. These workshop products outline the monitoring criteria and maintenance for the vegetated hammocks. For the last 2 workshop products, Recover made recommendations on how to define the success of the vegetated hammocks and developed a set of criteria for determining future success. Criteria for success changes based on hammock age, hydrology, vegetation dynamics, topography, and wildlife usage.
So for me as a wildlife biologist, we'll know if these vegetated hammocks are successful if we have a native component of both wildlife and plants. And so if we have things like birds foraging on the native fruit on the tree islands, or alligators nesting, turtles nesting, and things like that.
These 8 workshop products and a summary of the workshop were provided to the SEP North design team, who will then use these recommendations in the design and construction of the vegetated hammocks in the Miami Canal. This Recover workshop brought together more than 50 experts from close to a dozen organizations to inform the design, construction, monitoring, and maintenance of these vegetated hammocks.
I feel like a workshop like this is really important for any restoration effort. It's particularly important for this one because no one has ever tried to construct habitats in an area that's been degraded for 100 years. And so I thought it was really critical that we bring in all the people, all the scientists that have an understanding of forested wetlands to help us design such a project.
It's an excellent opportunity to have a workshop like this to gather together scientists from all different types of disciplines and managers from different areas and get to talk about the shared vision for restoration under the Comprehensive Everglades Restoration Plan.
So the workshop that we held is really important in terms of how we move forward with a collaborative and cooperative restoration project. It provides an opportunity for us to share what we know about the ecosystem, to look at the new science, to understand where we agree and where we disagree on different aspects of the science, but also in how to move forward. And so it allows us to then build that mutual understanding and respect and trust that will ultimately help us do a better job with Everglades restoration.
This workshop was just one early step in the long process of planning and implementing the project. Over the next few years, the vegetated hammocks will be constructed and then monitored to ensure their success. Backfilling the Miami Canal and constructing these vegetated hammocks will help re-establish the historical hydrological connectivity of the water conservation areas and Everglades National Park, as envisioned in the Comprehensive Everglades Restoration Plan.
This workshop definitely met my expectations. In fact, it exceeded my expectations. There was an enthusiasm here that really pointed to the people being engaged to solving this problem and dealing with the uncertainties of constructing tree islands.